Voyager 2's journey to the edge of the solar system revealed something we never saw coming. And it's far from good news as it crossed into interstellar space. The spacecraft uncovered a weakening heliosphere and a chaotic red sea of charged particles. These findings raise alarms about Earth's protection from cosmic radiation and the dangers lurking beyond our solar system. What does this mean for the future of space exploration and even life on Earth? Let's dive into the unsettling details. Stay tuned as we explore the shocking discoveries at the edge of the solar system. Foundations of deep space exploration. Deep space exploration didn't happen overnight. It was built on decades of scientific progress, technological innovation, and humanity's unrelenting curiosity about the universe. The foundation for venturing beyond Earth's orbit was laid through a combination of early space missions, Cold War competition, and groundbreaking discoveries that pushed the limits of what was possible. Music. The journey began with the space race in the 1950s and 1960s, where the United States and the Soviet Union competed to demonstrate technological and scientific superiority. The launch of Sputnik 1 by the Soviet Union in 1957 marked a pivotal moment. As the first satellite to orbit Earth, it shocked the world and forced the US to accelerate its space ambitions. In response, NASA was established in 1958, and the era of space exploration officially began. Early milestones focused on near-Earth targets. The US launched Explorer 1 in 1958, its first successful satellite, which discovered the Van Allen radiation belts surrounding Earth. The Soviet Union followed with even more ambitious accomplishments, such as sending the first human, Yuri Gagarin, into space in 1961. This led to President John F. Kennedy's bold declaration that the US would land a man on the Moon. A goal achieved with the historic Apollo 11 mission in 1969. But while the Moon was the immediate focus, scientists were already thinking bigger. Missions like NASA's Mariner program paved the way for interplanetary exploration. Mariner 2, launched in 1962, became the first spacecraft to successfully fly past another planet, Venus, revealing it to be a scorching, inhospitable world. Mariner 4 in 1965 sent back the first close-up images of Mars, forever changing how we viewed the red planet. Advances in spacecraft design, like the development of radioisotope thermoelectric generators (RTGs) for power and the use of gravity assist maneuvers, were crucial. These technologies enabled missions like the Voyager program to venture into the outer solar system, setting the stage for humanity's most ambitious explorations. From Cold War rivalries to groundbreaking discoveries, these early efforts laid the groundwork for everything we know about deep space today. Cold War origins and the space race. The origins of deep space exploration are deeply tied to the Cold War, a period of intense geopolitical rivalry between the United States and the Soviet Union. This competition wasn't just about military power. It extended into science and technology, creating the space race, a monumental chapter in history that laid the groundwork for humanity's exploration of the cosmos. The space race officially began in 1957 when the Soviet Union stunned the world by launching Sputnik 1, the first artificial satellite. This small beeping object orbiting Earth wasn't just a technological achievement. It was a symbol of Soviet power and scientific superiority. For the United States, it was a wake-up call. The fear of falling behind in space technology, particularly its military applications, pushed the US government to act quickly. In response, NASA, National Aeronautics and Space Administration, was founded in 1958 to coordinate America's efforts in space exploration. Early achievements in the space race were dominated by the Soviet Union. After Sputnik, they sent Laika, the first living creature, into space aboard Sputnik 2. Then in 1961, Soviet cosmonaut Yuri Gagarin became the first human to orbit Earth aboard Vostok 1. These milestones were not only scientific achievements, but also significant blows to American pride and prestige. The US responded with bold ambition. President John F. Kennedy, in a historic 1961 speech, famously declared the goal of landing a man on the Moon before the end of the decade. This set the stage for the Apollo program and the historic Apollo 11 mission in 1969, when Neil Armstrong and Buzz Aldrin became the first humans to walk on the Moon. It was a defining moment in the space race, cementing America's lead in space exploration. While the Moon was the primary focus, the space race also advanced technology for deeper exploration. The Cold War rivalry spurred rapid progress in rocket technology, satellite communications, and spacecraft design, all of which would later support missions like Mariner and Voyager. These achievements born from competition became the foundation for humanity's journey into the vast unknown of deep space. Key early U.S. space missions. The early days of U.S. space exploration were all about pushing boundaries and proving that humanity could reach beyond Earth. These missions laid a crucial foundation for future space exploration, including missions to the Moon, Mars, and even interstellar space. Each mission was a stepping stone, advancing technology, scientific understanding, and the nation's capability to venture deeper into the cosmos. One of the first key milestones was the launch of Explorer 1 in 1958. This was the first successful American satellite and it marked the United States' entry into the space race. Explorer 1's mission wasn't just symbolic. It carried scientific instruments that led to the discovery of the Van Allen radiation belts, a major breakthrough in understanding Earth's magnetic environment. This achievement showed that space exploration could yield valuable scientific data, opening the door for more ambitious missions. The Mercury program, which began in 1959, was the United States' first manned spaceflight program. Its goal was simple but challenging: to send a human into space and return them safely to Earth. In 1961, astronaut Alan Shepard became the first American in space aboard Freedom 7, a suborbital flight that lasted just 15 minutes. The success of the Mercury program proved that humans could survive and operate in space, setting the stage for more advanced missions. Next came the Gemini program, which focused on developing the skills and technology needed for lunar exploration. From 1965 to 1966, Gemini missions tested spacewalks, orbital docking, and long-duration flights, essential for the upcoming Apollo program. Gemini astronauts spent up to 2 weeks in space, proving humans could endure extended space travel. These early missions culminated in the Apollo program, with its crowning achievement being the Apollo 11 moon landing in 1969. The Apollo program demonstrated not only technological prowess, but also humanity's ability to explore worlds beyond Earth. These groundbreaking missions laid the groundwork for future space exploration, from robotic probes to interstellar missions like Voyager. Technological breakthrough. Technological breakthroughs have been the driving force behind humanity's ability to venture into space and explore the unknown. Deep space exploration in particular required innovative solutions to overcome challenges like vast distances, limited power sources, and precise navigation. These breakthroughs not only made missions like Voyager possible, but also redefined the limits of what we could achieve in the cosmos. One of the most significant advancements was the development of the gravity assist maneuver, also known as the slingshot technique. This revolutionary method uses the gravitational pull of planets to accelerate spacecraft without additional fuel. First successfully utilized during the Mariner 10 mission to Mercury in 1973, gravity assist became a cornerstone of missions like Voyager, allowing spacecraft to visit multiple planets in a single mission. For Voyager, this technique enabled the grand tour of the outer planets, slingshotting past Jupiter and Saturn to reach Uranus, Neptune, and eventually interstellar space. Another critical breakthrough was the invention of radioisotope thermoelectric generators, RTGs. Unlike solar panels, which are ineffective in the dim light of the outer solar system, RTGs generate power from the natural decay of radioactive isotopes such as plutonium-238. This reliable power source made long-duration missions like Voyager possible, ensuring the spacecraft could continue to transmit data decades after launch, even in the cold, dark reaches of interstellar space. Communication over vast distances presented another challenge. NASA's Deep Space Network (DSN), a global system of giant radio antennas, allowed spacecraft like Voyager to send data back to Earth, even from billions of miles away. The DSN had to be incredibly sensitive, as signals from Voyager 1 now take over 22 hours to reach Earth at the speed of light. These technological breakthroughs, gravity assist, RTGS, and the DSN, enabled humanity to explore the distant corners of the solar system and beyond. They remain a testament to human ingenuity and continue to shape the future of space exploration. Voyager program inception and launch. The Voyager program began with a vision to explore the outer planets and venture into the uncharted regions of interstellar space. Launched in 1977, the program emerged from a rare opportunity, a once-in-one 176-year planetary alignment that allowed spacecraft to use gravity assists to visit multiple planets on a single mission. This alignment, combined with advancements in technology and a growing curiosity about the outer solar system, made the Voyager program one of NASA's most ambitious projects.